It's finally arrived. Everything's here. Shanghai to Ningbo to Long Beach, then to Phoenix. Tariffs are paid, fees are paid. Everything's looking good. Inverters are in this box. Boxes over there, just all panels. Walk around there. Mounts. That box had a little freight damage. Hopefully all the mounts are there, otherwise I got to make a couple. And the balance of the panels. So, got a little work to do. The crane is here. Everybody's excited. Very simple construction, unistrut. So we just put one unit in there with the bolt. Actually, we'll put a bolt in from the back. Yeah, we put one unit in from this side. Line that up about center. Make sure the hole's at the top. Back one's a little taller. The idea behind that is we got 30-degree angle to the sun. What I did is I used a program called PV Sketch, and they have a free version that you can use in limited capacity. So I did that and just laid out the roof, set the azimuth to the sun, your latitude and longitude, and it'll calculate your annual output of your solar panels. So I just experimented with different angles, went in like 3-degree increments, and basically at about 30 degrees was my maximum annual power output. So it was just, so it's a lot of panels in this area are at 20 degrees, which probably get a little more power in the summertime, but this yield was the year-round average. We'll see how it works out. This is pretty easy construction. If I really wanted to get them at, if I was disappointed with my summer output for some reason, you know, I could just pull these back ones out, cut them off a little bit, lower it back down, bring it down to 20 degrees. So, but I think the 30 is probably going to work out just fine. Got all the mounts up on this side. Now, next job is to remove that little fence that's along the edge there, because that'll cause a shadow on my panels. through and show a detailed version of how each of these racks is built up. Right now we're 2 days after the winter solstice, so it looks like I'll probably stop generating electricity at about 3:30. Not too bad, and that will just improve as the days get a little longer. Not a real complicated system. Long leg in the back, short leg in the front, swivel piece here, kind of adjusts to the angle. Then there's one bar that runs kind of crossways across the panel, and then a long rail that runs this way, and then clamp mounts, end clamp mounts on the middle, dual clamp mounts between the panels, and then end clamp mounts again on that side. It's incredibly stiff, all tightened up. It is not going anywhere. This is really solid. There's a little flex in the panel, but absolutely no flex in the mount. Across the back of the mount, I've mounted a couple of pieces of unistrut, and then so I can hold these two boxes. This first box is a rapid shutdown. That's required by the newer electrical code. So the two strings in each section will get wired into this. This can actually handle 3 strings. And then from there it'll be wired into this E-stop, which will be mounted near the disconnect. So in case you ever have to do a rapid shutdown, or the fire department has to be out for any reason, they just hit this button. It'll shut down the electricity to all the panels at this box. That cover will screw on. Then this box, which probably, I don't know if it's required or not, but up here at this level I've got it. So here's further disconnect, and then ground fault protection, surge protection through ground for the 2 strings. So the panels will be wired into here, and they'll go into the combiner box, and then it'll run into a conduit, and all 3 of these sets of 2 strings will meet up at the inverter down below. I'm not really happy with the way this is, so what I'm going to do, pull it off. Come on. Screws tight. There we go. And pull that off. I'll mount another rail up here in the center. These are just little spring clamps, or spring bolts, I guess. So they go in there, twist. Spring holds them up against it. Makes it really nice. This unistrut stuff locks together pretty rapidly. Put that in there. Need a couple washers. shoe. Cap's a little narrow. These just go down, push to turn. They have a unique little shape. So it's round on one side. So basically they go in horizontal, go up, and then they're square on this edge. That locks it in place. This has a little plastic housing across it. That acts as the spring, kind of hold it in place. And we can drop that on there. Too close together. Much better. Probably being a little anal, but that's the way I get sometimes. In the end, I'll be a lot happier. This isn't sticking way up. It looks a little more purposeful. So I'll go ahead and change out the other two. We got a little video of Bill bending his first piece of conduit. Jog it up till it's tight.
Do what now?
Hit the bend button until the conduit gets tight. See where the hook's going to grab it?
Oh, that hook right
there. There you
Gotcha.
go. Stick your finger in there.
No.
Okay, good idea.
All right.
Okay,
And I'm
bend it
gonna
up
go
tight.
for 93.
Bend it up. Is it touching yet? Okay.
It's bending it,
All
yeah.
right. So go to about 93.
93.
That'll allow for about 3 degrees of spring back.
Right on it, right?
Yeah.
1, 2, 3. Okay.
Okay, now hit return. Go to about 45 degrees.
Okay.
Now pull the conduit out.
By pulling it out, I just.
Lift up on the back, on the infeed side there. Lift up on that and turn it a little bit. Boom, you're out.
How about that?
90-degree bend. We'll put a square on it. So we're going to do an offset bend. We need 10 inches.
Okay.
And now we're going to do a 30-degree offset, and we need to offset 22 3/4 inches. So the multiplier for a 30-degree offset is 2. So we want from that 10-inch mark, we want to go to 45 1/2, which from the end of the pipe would just be 55 1/2. Be a little easier. So we'll make a mark at 55 1/2. Okay, now let's go over to the bender and do the bend. So now we're putting the conduit in a bend. Line the first mark up with the leading edge of the hook. Now jog it forward so you can check your mark. Yeah, jog that over till it's tight. Double check that you're on your mark.
Right on the edge, or?
Yeah, right at the edge.
No, that's right.
Okay, now we're going to bend to about 32 degrees. That'll allow for 2 degrees of spring back.
That's perfect. 32.
Yep. Okay, now go return to about -4. -4. There you go. Now you can slide the conduit forward. And then you want to rotate it 180 degrees so that this tube's pointing straight down. Line up your mark. If we had a level here, we could level it up, but we don't have a level. Now we want to line the other mark up with the leading edge of the shoe.
Like this.
Yeah, it doesn't have to be exact, but, and then make sure that's pointed straight down. Okay. And now we're going to go to the same 32 degrees. Whoa, whoa, whoa. Oh, sorry, I couldn't read from here. You're fine. 32. And down, yep. And that should be a 22 3/4 offset. I've got these bases that came with the system, and some unistrut left over from running those horizontals. I can just put that in there, take a conduit clamp, boom, clamp these in to support this free span across the roof where the offset is. Looks good. Let's see. I may not, because the way this roof kind of slopes in two directions. This we may just have to balance it by eye. Step back and take a look. I'd say we go with it. Now, one thing I need to do is get these two boxes connected together. The lines from the solar panels will come first into the emergency shutoff, and then it'll connect to this box. I could have just ran photovoltaic wire. There's already little nice little compression couplings on it, but on my plan that I drew up for the city, I said that this connection would be done with 3/4 EMT conduit, and I was going to drill just a hole to go back and forth, but I think I'm going to use these existing holes in the bottom. I'll just come with a 90 off of that box, and then a 90 up, and then come into this connector here. So let's go ahead and measure up the 2 pieces of conduit I need to cut for each of these. And let's see, we're going to go from there to there. Let's say that's 9 3/4 to the center from the landing there, about through. That's probably three-quarter. So we'll cut in 3 pieces 9 inches, and then we'll pop that on. See where we're at, and then we'll measure this little piece. So let me go cut 3 9-inch pieces of EMT. Got my little short piece here. This one I'm not really too worried about the length, because I can adjust that wherever. Oh, now so this will slide over that. Yeah. So, and my measurement was off a little bit, but this one I need to be a little more accurate with. Let's go 2 3/8. I call that plenty tight. And now then, put that right there. There we go. Okay, so that'll match the plan. We got so the one string will come into this connection, one string will come into this connection, then the exit from the strings will go through here into that, along with the signal wire for the 2 signal wires for the e-stop switch. One more thing I've got to do is there'll be PV wire running between rows to connect the strings together, because all the rows, there's 5 rows in each of the groups, all have to get to this one box before this PV combiner before it goes out there. So the PV wire that comes between the rows, you know, I could just kind of lay it across here, but I want to keep it up so it's not a trip hazard, so I'll run just a piece of conduit. This is a piece of 1-inch EMT, and then I can run the wires through here and connect the strings together. So on that, I'll just I got some cheesy little U-clamps. Make a nice solid trip hazard. So now when I come up here and I'm walking around for whatever reason cleaning the panels, I won't be snagging anything on the PV wire. Plus it'll give the PV wire UV protection All the wire will be tucked up underneath the panels. Stuff going between here will be protected inside this EMT conduit. Should last a very long time. For the last piece of conduit, I've had to basically chew through the wall with a small drill, hammer, and a chisel, and I got it lined up. Looks good. That side's much more attractive than this side, which is important. And now I've just pre-bent this 90, so I just need to cut this. I think we'll make our cut on that end first, and then we'll cut this end, fit it up. Well, that's exciting. The last piece of conduit's in. The next step is to go ahead and get some measurements, go down and buy some wire, start pulling some wire. I've got to make jumpers for the PV panels, and I think that's about it. Oh, I need fuses for that fuse box. First thing to wire in, just kind of working myself from the photovoltaics back to the panel meter. So we're starting by wiring all the panels together. They need to be connected in series. So positive to negative, positive to negative. Some of the panels, the cord doesn't reach from when the inlet box on the panel is, kind of the same. There's that space down there, so I had to make a little patch cord to connect the cords. Then it's just a matter of connecting. So we've got the positive here off of this row, which has to connect to the negative of the row behind us. That's why I put these conduits in that go back and forth between the rows, so the PV wire is well protected. So it's just a matter of routing these up. Strip somewhere between 5/8 and 3/4 of an inch off of the end of the wire. Leave it. Get the MC4 connector. See my helper right here? Hey Lola, say hi. But that we just, it goes into the crimp gun. Key is to get it straight. Make sure all the wires are inside the crimp and that the little ears go up in the groove like that. And then probably can't see it, but maybe I'll do a detail of one, but that folds over nicely, engages that completely. Press it until it snaps into the connector. It's got a little weather protector on the outside. And just tighten that up until the gap is 0. Once the connection's made, just plug the MC4s together. Make sure that they go in till they snap. You hear a little click. I've got these steel clips. You really don't want to use wire ties on a solar project because it's going to last a lot longer than the wire ties will. Let's see. Let's put that one over there. The little S-shaped clip. Large side of the S holds 2 cables. The small side of the S just clips right onto the aluminum frame. Snap into place. And then this is the 8th panel. So there's 2 rows of 3 in front of me. So this would be 7 and 8. This one will go back and connect to the positive side of the emergency shutoff switch. So we'll go ahead and keep running the cables and move on to the next phase of wiring. We're at the point now where we can start doing the checkout. Everything's wired. This is the first point, the strings, string 1 and string 2. So this string has 8 panels. This string has 7 panels. Come into the rapid shutdown box. So what we want to do, we can unplug this, make sure it works. So 333 volts on the 8 panel string. 296 volts on the 7 panel string. Across here, 0. Across here, 0. Plug this back in. I don't want to keep running up and down because of the RSD, so now 296 volts on the 7 string, 334 volts on the 8 string, open this box, move the meter. I don't know if I can put the meter where we can see it. So we're coming in. Brown is positive. Let's see. Yeah, brown is positive. So here from PV1 is coming in from the RSD. 333 volts there. 296 volts there. Polarity is correct. Turn those on. We're going to, let's see, come out of that string. 333 volts. 296 volts. Polarity is correct. So I'll check out all the other RSDs and get it checked out, and then we can go down to the panel. We can check out the photovoltaic voltage at the inverters. We'll start with inverter 1. Brown is the hot. Blue is neutral. We're getting 332 volts. And this one switches. We're getting 292 volts. Head over to the second inverter. Mainly we're watching polarity. We don't want to see a minus sign, so that's 332. Flip them over. We'll go 293.1. Sun's going down a little bit. Since we've been up there, we've lost 3 volts. Inverter number 3, 334.5. Polarity is correct. Flip this. 297.2. 0.3. Okay, we've got our PV voltage is all fine.